The following content has been provided by RWTH Aachen University.
Next up, the hypothesis. The hypothesis is a tricky thing because this is going to be your more precise way of formulating the question or the thing that you think is true and that you want to prove. It predicts what the outcome of the experiment is going to be. So usually the claim is that you're saying, if I change the independent variable, like the color of the buttons, that's going to have an influence on our dependent variables, like how many times it gets selected by the user. And the goal of the experiment is, of course, to confirm this research hypothesis. We often call this H1. And Einstein said, no amount of experimentation can ever prove me right, but a single experiment can prove me wrong. So we have to be aware that we cannot really completely, without question, prove the hypothesis. We can just show that the inverse of the hypothesis, the null hypothesis, is not true. The null hypothesis typically means that there is no influence from the independent variables onto the dependent variables. And we can show that this is wrong with a certain amount of confidence. That's why it's called confidence intervals, for example, or significance, that this is wrong. And if we can show that, then we can, that's a sort of a naive view, we can accept that the inverse of it must be true. So H0, the inverse hypothesis, is usually a very precise statement, so we know the probability that each H0 then is incorrect if we're done. For example, back to the video game thing, the average words per minute between gaming and non-gaming groups are equal. If they're equal, that's a precise thing, so we can measure if there's a difference. We can show that they are not equal at a certain level of confidence. The data should then indicate basically that there's a very low probability that H0, the null hypothesis, is actually correct. So there's a very high probability that H0 is incorrect, which means that our research hypothesis, H1, is actually correct. I know this sounds weird, but doing it that way around will make sure that you're not overstating what you have actually shown in your experiment. Now here's something weird. So your goal is to reject the null hypothesis, right? If you don't manage to reject your null hypothesis, however, it doesn't mean that you can accept the null hypothesis. Why? So we've got this gaming, non-gaming group here. Let's say you just do your study with 2 people. And you can't show this effect. You can't show that the average words per minute between gaming and non-gaming are equal. That doesn't mean that you can accept it, because the number of people might just be too low, so it's statistically irrelevant. Right? You haven't actually gotten to a significant result. So be careful if your experiment fails. Don't just say, oh, I've shown the opposite of what I was trying to show. You haven't. You've just failed to show what you were trying to show. That doesn't automatically give you the inverse result reliably. In short, this will probably require you to read up on statistics, talk to a psychologist or statistician to make this kind of stuff work. We frequently work in this ourselves, and it's a tricky area to get your research right, and so that you're proving stuff that is actually valuable. Let's do this with another little exercise here. We're now going to identify the research hypothesis and the null hypothesis for our scenarios. So the first one was the one with the security training program. What do you guys say would be a good hypothesis here? And this is not hard, right? This is not a terribly difficult thing to do. Yeah?
Yeah, the hypothesis is that people who attended a security training program use more secure passwords.
OK, so you'd have to have a measurement for the security of passwords, and you would say then the level of security for those kinds of passwords that these people pick, on average, is higher than the average level of security of passwords that people pick that didn't take their security training, right? So there's not a big difference here to what says on the wall, but you notice that we're becoming a little more concrete. We're becoming a little more precise. We're getting to something we can actually measure, right? We're replacing sort of hazy notions, use more secure passwords. We're trying to make them more, operatable, so we can actually work on them and run studies on them. What about the second one, the joystick versus trackballs? What would be an example for a hypothesis here? Fairly easy? Or maybe, sorry, before we get to the second one, what's the H0? What's the null hypothesis for the first one?
They are equally secure for both groups.
Exactly. So whether you took a security program or not, you will create, on average, the same level of secure passwords. So, yeah.
Wouldn't the exact null hypothesis be that people who have not attended a security training program generate and use, on average, at least the same amount of security in their passwords, why not more?
It's a good point.
It's not only equal.
That's a good point. We have to make sure we can ask. We can put up different H1s. If we put up the H1 that says the two differ, then I guess the inverse is they do not differ. If we say one is higher, then yes, the inverse of that would be they are the same or even lower. You're right. So turning around is important in this case. For the second one, what about the H1 and H0 there? Yep.
Well, the H1 would be that effectiveness of joysticks and trackballs differ.
Let's get a little more measurable, because effectiveness, I wouldn't know how to measure that.
Well, then you could say that people using joysticks or trackballs they're both more precise.
Okay. So there's a lower average error in target acquisition when using, I don't know, maybe joysticks than trackballs, if that's the claim we want to make, right? We have some idea in our heads probably as we do this. So if we think joysticks are more effective, then we should formulate the hypothesis that way. Or we could just say there's going to be a difference if we don't know which way. It also might make sense to actually, for this one, to have one hypothesis that says for moving targets, joysticks are faster than trackballs. If that's, then you've narrowed it down and you nailed down your second independent variable, moving or static targets, and you've made it into a more processable experiment, because now you need to only study moving targets, find out the data for those results, or find the results for that experiment, and then determine your hypothesis. And then, of course, the inverse is there is no speed difference, or maybe the other one is even faster, depending on how you formulate H1. And then in the third case, research team with the virtual teams instant messaging. What would be an H1? Yep.
Teams who would use video instant messaging can work on the same project faster than teams who use only text.
They complete the project more quickly, solve the same question more quickly. Yeah, and that's, of course, meaning that if the question can really be only solved in sort of to one degree of quality, right? If you have something like write a text editor, then I could be done more quickly, but I could write a crappy text editor. So oftentimes, that's the challenge with these kinds of productivity tools and evaluating them, that you often need to measure the quality of the outcomes of using the tool to do something. And that's very, very involved.
This content was provided by RWTH Aachen University.